Purpose of this network is to bring people together from across the public sector and various private industries, and with the aim of fostering dialogue about property data and the property data system, information system, sharing news and updates and case studies, getting design input and feedback on things like data improvements, and exploring new avenues for data and system improvements. So before I go into the agenda, I'll just give the opening karakia. Paia te mātauranga, kia marama, kia tupu, kia tiaki ngā whenua, ngā moana, ngā arawai. Kia whai take ngā mahi katoa, aroha atu aroha mai, tātou ia tātou, toi te kupu, toi te mana, toi tū te whenua, homie, huie, tai kie. And that translates to pursuing knowledge for understanding, developing and caring for the lands, bodies of water and waterways, seek purpose in all that we do, let us show respect for each other, hold fast to our language, hold fast to our spiritual strength, sustain the land, gather and go forward together. So today we've got a pretty chock-full agenda as usual. We have first up a selection of news and updates from across Land Information New Zealand, presented by various relevant stakeholders. And then we move to external case studies with first up Wellington City Council talking to their subsurface mapping program. And we'll have Denise Beasley, the program director, talking to that. And then we have Deb Burgess from Ministry for Environment talking to their Lucas land use map. And then Richard Law from Manaaki Whenua Land Care Research talking to land use classification using a discrete global grid system. And then we come back to Toi Tū Te Whenua segment where we have Andrew Freeth from our policy team sharing some news and an outline of our planned rating valuation rules review and outlining what can be expected from there in the near future, and some discussion on that I'm sure will be welcome. So LINZ news and updates. So we've got updates on NZ Addresses, NZ Suburbs and Localities, NZ Properties Hybrid Layer, the key data sets for resilience, the LINZ data service and some news and updates from there, modernising land online, a quick update on that program, and overseas investment, some new dashboards that are publicly available. So talking to NZ Addresses, we have Trent Gulliver, our manager addressing. Fire away, Trent.
Lovely, thank you very much there, Ben, and kia ora everybody. So I've got a really nice trifecta of updates for you today. So the first being NZ Addresses. So just a bit of a recap on that. So NZ Addresses is the result of our comprehensive addressing work, or a key result of that work, in which we went out to identify, to validate with confidence addresses that were missing from our system. And so we went about that work. We've identified that there were over 135,000 missing addresses. And so we went about making it available. And we've done just that through moving NZ Addresses out of pilot. And so that happened at the beginning of this year. And so NZ Addresses has now become our authoritative address layer, and it supersedes NZ Street Address. NZ Street Address will be available, continue to be available and maintained up until end of June this year. And so for those that are still to transition across from NZ Street Address to NZ Addresses, yeah, I certainly encourage you to do just that. A big thank you to our customers that have helped informed NZ Addresses. It wasn't just a simple, just a new data set. We've improved things. We've tweaked things in terms of the data table. So all in all, it seems like a great data set for our users. So big thanks again. Good there, Ben.
Sorry, Trent, just before I go to the next slide, I forgot to mention to everyone, if you do have a question at any point, feel free to do the hand raise, hit the hand raise button, and we'll come to you. And we want to, definitely want to hear questions and feedback from the audience. So just please do hit that button. And there is some time allowed with the external presentations, especially for some Q&A and discussion. So really want to hear from everyone on the call. Sorry, we'll go to the next.
That's great. Yes, please. Thank you.
Slide.
All righty. So NZ Suburbs and Localities, a bit of a recap in that space too. That sort of relates to work that's been undertaken as we transition responsibility for the data set of Suburbs for New Zealand from Fire and Emergency New Zealand to us here at Toitū Te Whenua. And so we're well down the track of that now. And so all going to plan, we're going to publish that data set before June this year. So at the moment it's available in pilot form. It has been in pilot form since September. It's not a simple sort of lift, shift and drop. It has involved, again, a real key aspect to our work, and that's the voice of our customers. So customers have provided information, some insights, some desires, some needs, expectations, and so we've worked in accordance to that. The data structure has been simplified. We have an alignment with the New Zealand Gazetteer, which is administered by the NZGB. And we've also gone about tweaking things in terms of the systems and processes and how we maintain and manage the data going forward, and how we interact with people that are interested in the data and providing change requests, or they've got queries around it. So as a result of that, we've generated two new apps. One's going to be for our internal use to help manage and maintain the data. We've also developed an external app which will be used by key contributors of data, sort of likely to be TAs, but just noting that anyone can make a request for a change, and we'll go through a really considered and well documented process. We've got guidance material being finalised. We've got principles, requirements and rules around the data and its use and how we update and change. And so it's all, to me, to us, a really nice package of things that we're delivering on there. A key aspect of the change request is going to be the formation of a change request review panel, which involves a number of interested parties, including the NZGB, TAs, the Communications Centre that's sort of run from Fire and Emergency New Zealand, and there's some other interested parties too in the mix there. But all that information will be sent out in our correspondence that we send out in due course. When we release out of pilot, it'll be well and truly supported by good communications around the documentation, next steps and timeframes and what have you. On timeframes, like we've done with NZ Addresses, there's going to be a transitional period where the data set, the NZ Localities by Fire and Emergency New Zealand, will be available for a further 6 months, whilst the NZ Suburbs and Localities is moved out of pilot, and that's to ensure that everybody has sort of the due time to be able to make that transition if there's any systems and processes that need to be updated. Yeah. Right, that's about it for that one. Thank you, Ben. Excellent. All righty. So the third in this trio is the NZ Properties hybrid layer. So that's something we've mentioned on a number of previous occasions there. So a bit of this particular layer is about having something that is useful for customers whilst we're en route to achieving a bigger goal. And so that bigger goal is the formation of properties by connecting property information in accordance with the property data management framework. And some of you might have heard of that as the PDMF. And so it's a particular way of forming these properties. It's from a valuation perspective. And so on that note, there's an image there saying we've got 97% achieved in terms of onboarding. That relates to onboarding TAs. So we're almost there in terms of onboarding the data into our system. The issue that we have, even when we've got the good data in there are some issues with the data. There's some things that need to be resolved as we form properties. And so we're undertaking that work as we speak. It's quite a piece of work though that's ahead of us in that space. And so that's where the NZ Properties hybrid layer comes in. It's an interim measure to ensure that you, our customers, have something that's useful in the meantime. So the way this hybrid layer has been put together is that we've got a hierarchy. So at the top of the hierarchy is a unit of property, which is that the property view through the PDMF. If there is an instance where we haven't connected the property information to form a unit of property, the next piece of data that can go into that space will be a title view of a property. If a title view isn't available, then the third piece of data comes into play is the parcel view. And so the combination of the three in that order of sequence or hierarchy is forming the NZ Properties hybrid layer. So that is currently going through the final stages of testing, and all going well, we hope to release that into pilot in May this year. So not too far away. It is worth noting and reiterating that this is not publicly available data. So we're able to share this with other government organisations. Given the licensing restrictions based on the type of data going into it, unfortunately, at this point in time, it's not available for all users. All right, Ben, I think that's it for me, unless there's any questions.
Sweet. Next up we have, thank you, Trent. Next up we have Susan Shaw, our Senior Resilience Advisor, talking to key data for resilience.
Kia ora, thank you, Ben. As Ben says, I'm Senior Resilience Advisor at Toitū Te Whenua, and basically my role is to bring that customer view into Toitū Te Whenua. So Trent's talked quite a bit there about how important it's been to hear what our customer has to say. I just happen to use emergency management to paint a picture to everybody at LINZ about why some of these data changes are so important. And it's a real pleasure to be able to do that, and it's fantastic to see some of the changes that have happened over the last 4 years while we've worked on this. So Trent's talked to you about NZ Addresses, and we got a real clear message from the emergency management community that we really needed to up our game and improve our addressing data set. So it's really great to hear the positive feedback that we're getting back now. So that's a good tick. We've also heard about the transfer of NZ localities from fire and emergency, and so that's we've got 12 key data sets. So I've just put in the chat, if you're interested in the key data work in a bit more detail, there's a story map that tells you much more about it. So Suburbs is the most improved of the 12 key data sets, and imagery is the most improved of the LINZ key data sets that we are responsible for. So, and overall KiwiRail's rail data is the most fit for purpose for emergency management. So we've had some real good wins. It's fantastic to be a small contribution to some of that improvement, because I know not only is that important for emergency management, but for the ripple effects across the wider geospatial community, as I always like to say, are really vital too, especially in this property space where we're all here today. So what next? So Ben, could I get you to launch the poll, please? Thank you. So it's gosh, it's 4 years at least since we went out to the emergency management community and asked them what were the most important priorities that we should work on. So if you remember back then, there was no funding for PGF LiDAR. There were no population grids put out by Stats. There was no chance of LINZ publishing REST services for some of its data set. And that NZ localities data was a shapefile in a Dropbox from Fire if you knew who to contact. So a lot's happened. And now's the time for us to go back out and ask, are we still working on the right priorities? So what you've got there is a poll, and that's the order that the emergency management community said the data sets that most urgently needed improving. So what I'm keen for you to do is just think about what data improvements you'd like to see happen and just reorder them. So like if buildings you thought was the most important thing we should improve, just move that to the top of the list. Or if you thought we've got LiDAR all sorted, you could move that one down to the bottom. What I'm not trying to suggest that should be your order at all. But if you just want to have a go at that poll while I just talk you through a couple of things that we think is coming up next. So we've talked about the property boundaries this morning. That there's very little attribution in that data set. And so I think one of the most important things we can do is to go back to the 67 TAs and get their permission to be able to release that data set under CC BY and make it openly available, because that would be really important that we're all using the same property boundaries, certainly in a response and in our BAU work. We heard loud and clear previously that it would be important for buildings. Again, that's come out of pilot since we started this work, for buildings to have useful attribution. So the address of the building, the height and the use, if we know that. And probably what's most front of mind for us is the closed roads in an emergency, and particularly with the Auckland flood and Cyclone Gabrielle. That's obviously been a really important data set. And I just want to share this slide with you. Could we go to the next slide, please, Ben? So what we've got here is a screenshot of Waka Kotahi's journey planner, and this was taken on the 27th of, I got that right, the 28th, so Saturday the 28th of January. And I was in the car and I was listening to Kieran McNulty, the Emergency Management Minister, saying, forget Auckland, if you need to know where your roads are closed, go to Waka Kotahi. And as a minister, he should be able to say that, right? The Waka Kotahi is responsible, we think, for all the roads. But if we could go on to the next screenshot, this is actually, so we need to do 2 clicks. And one more. Sorry. So this is exactly the same time, and this is Auckland Transport. So even just the colour choice here is interesting. But you see there's, because Auckland Transport includes the state highways and the local roads, it paints a much different view to what the Waka Kotahi closed roads information does. And I certainly know, I'm based here in Nelson, and during the Nelson Tasman floods, in my local area, people were saying, oh, it's okay, I can go over the Applewood Bridge because it's open, because it looks open in the Waka Kotahi page. But of course, local knowledge and the local council data in RAM shows us that no, plenty of roads were closed and communities were isolated, and it was a real big issue. So I think this is one of the key data improvements that will come to the fore for the next 3 months. So that's really good information there, Nahi. Thank you for that. I will need to find out more about that, because I thought it was the situation at the time. So that's really good to know that. Thank you. I still think there'd be more closed roads on there, though, wouldn't there, during the response, do you think? Or do you think I'm over egging it with that picture?
Sorry, I'm just going to come in with conversation here. There was another thing that was in pilot, which we saw from AT, but it was not particularly complete either. So this was actually put up well before the emergency. So I've seen it a couple of times, but it might be for a road closure of, say, 3 days, but they can do that anytime within the corridor access request time frame.
So what I'm trying to, the story I'm trying to tell here is a bit skewed, because it could be sometime over the next 3 months. Is that right?
That's right. So this is actually done for a completely different purpose.
Yes.
So what I can do is I can send something to the AT guys and see whether they can join in next time.
Do you work at Auckland Transport?
I'm working in Auckland Council, but I have quite a few ex-colleagues that are over there. And this is very similar to something I generated in about 2012 from the RAM and the corridor access requests process.
I would really
much happier about it now than I was then.
I would really appreciate following up with you. So obviously I need to change my tune because my story isn't, oh, go to Auckland Transport then either. It's even worse, right? We don't know where to go to get closed roads in an emergency that's current as of today and not in 3 months' time.
That's right. So I did encourage them to try and get their contractors to update it just before they went in to specify that, yes, this was the period. But as far as I know, if you actually look at the attribution, it's got a start and an end date in it.
And so that then it should be easy to do a map based on that, right?
If they update when they're actually going to start it, yes, rather than this is the road maintenance period. As I said, I think this was designed for quite a different purpose. So that maybe you could look at, say, Watercare goes and say, oh, Auckland Transport's going to be doing something on that road. Maybe we can combine them. But it's not really for an emergency situation.
I really appreciate you sharing that with me here and not letting me carry on and keep showing this image without getting my story straight. So I really appreciate that. Thank you. I think, Ben, we need to create a road network quarterly meeting so we can have more of a conversation about this. But how are we looking on the poll? What's people thinking is the most important data set to improve?
Sorry, bear with me while I view a result. So we've got at the top address suburbs, closely followed by roads, then LIDAR, property, population, building outlines, imagery, coastline.
Cool. So just real quickly, if addressing and suburb is the most important thing still to improve, what's the top improvement? You could put it in the chat, or you could take him, or you could tell us here.
I can't see chat at the same time.
I can see the chat.
Yeah, no one's said anything yet, but Denise Peasley's been really helpful. So Wellington's operations team would be happy to help with Susan's question about today.
Well, there might be some food for thought, Susan.
Yep, I got that. I need, before I move on, I want to know what's the most important thing we should do to address in suburbs, if you think it's the most important improvement we could make. Oh, Casey, Kim and Casey, thank you. More attributes and more attributes. Fantastic. Then that's what we shall take away from this session. If you've got any feedback on any of the key data improvements, or you'd like to be part of the discussions, then please just get in touch either directly with myself or with Ben. Cool. Thank you for your time.
Yeah, we'll share contact details with the slide pack after, so you can get in touch at any time. Cool. Thanks a lot, Susan. That was very interesting. Cool. And next we have Victoria Lindsay, Manager Open Data and Reuse, talking to some updates around the LINZ data service.
Cool. From me today, just we're going to provide a high-level overview of some key pieces of work that are happening in our space that would be of interest to you. So the first one is our progress towards a new user interface for the LINZ data service. So if you are also a customer of a similar sites like the Manaaki Whenua Addresses site or Stats NZ, MFE, you will see actually they've already migrated to the new UI. So go and have a look if you haven't already to get a bit of a taster of the sort of functionality and the way that things work, and from a workflow perspective, and what's going to be new and different. In terms of LDS, we've got a few sort of additional features that have always been part of our service that are still being developed. So we're still a couple of months away from moving ourselves. But I think some of the key things that would be really interesting, and this is really based on feedback from customers as well, and engagement to understand your sort of use of the service, is you'll have the ability soon to favorite data sets. That can be really helpful just from a usability point of view, to be able to revisit a particular data set, or then a particular collection of data sets that you always come back to and want to refresh. Also, there's going to be some improved sort of search and filtering technology there. Also, better integration with APIs as an access method in terms of the sort of export workflow. That workflow will change a bit, and so the services will be integrated as part of that workflow rather than what they have been is quite separate. So they're some of the key things that will be coming, and yeah, we're pretty excited about that. The next sort of thing I wanted to share is around point cloud data. So we are once we move to the new user interface, then the LINZ data service will be able to support LiDAR point clouds as well. So that, for us and for you, that's awesome, in that we have, you know, those variety of products from LiDAR in the single location, so you're not having to go elsewhere for that. So in terms of sort of at the moment, those point clouds are on open topography, so there'll be a bit of a progress that will happen around migrating that data over to the LINZ data service, and that's likely to start with putting the more recent stuff up on LDS, and then we'll be doing some work to sort of then populate our service with the older data that's sitting on there currently. Yeah, but that will be very awesome. There'll be sort of key formats you can download it in, LAS and LAS, and then some GIS formats. And there is also a streaming point cloud service that's being developed as well. The other key thing at the moment I wanted to raise is you are probably aware that we are LINZ is doing some work now to understand property owner data. So you may have received the survey that we have out at the moment, and there was also a communication that we sent out yesterday regarding a small change to the LINZ license for personal data. So this work is sort of happening on the back of an internal review, a sort of privacy impact review that LINZ did at the end of last year. And also, if you may have noticed, some recent public interest in this data. So that's sort of driven us to review the license and the way that we provide this. So it's part of the review is sort of checking in with public sentiment around the privacy of their personal information, as well as how we align with the more recent Privacy Act. And of course, how this sits alongside the sort of home of this data being a public register, which is always an interesting situation to be in. And so, yeah, I just wanted to communicate really that any changes over and above just this administrative one that we're doing around the license, they will not be made just in isolation. That there will be consultation in terms of if there is any changes, and as part of that, we need to really understand what the value is for you in using this data. So hold fire. We will be in touch with you in terms of with next steps and making sure that we've got the input that we need to make the right decisions. The other thing, yeah, so if you haven't seen the survey or that notice around the license change, then please get in touch with us at the email address there on the slide, and we can forward that on. And one last thing on a brighter note, as always, if we're always looking for good news stories, especially even in regards to owner data, it helps us to tell a good story around how our data is used. So please get in touch again if there's some great stories around the use of our data around building value that we would be able to share. That was it from me today. So if there's any questions.
Thanks, Vicky. No questions, no hands up, and no questions in the chat yet. There's just a comment from Kim that he's quite confused by the stats GUI. So Carl's reached out with an email address to contact. Yeah, and there's a question from Jared, but I think it's a resilience question about mobile coverage data. And is there any moves to try and get that centralised and available? Good question, but might be one that we have to come back to.
I'm just typing a response to Jared.
Okay, cool. Thanks, Susan. You're onto it. Sweet. Well, if there's no further questions for Vicky, we might just scoot right along. I'm conscious we are just running a bit over time. I'm going to actually skip the next two LINZ updates for the time being. We might come back to them later if there's time, but Denise needs to, from Wellington City Council, needs to get away to an 11 o'clock. So we better let her speak now. So yeah, welcoming Denise Beasley, Program Director, Subsurface Mapping Program at Wellington City Council. And so you can share from your end. I'll stop sharing and you can take over.
Okay, thank you, Ben. Kia ora. Thanks for the opportunity to share with you what Wellington's doing on behalf of all of Aotearoa and what it means in terms of greater information on what's underneath the roads and ground across our cities and country. So Wellington is creating an underground asset map, so a market twin, not a pure digital twin, and I'll explain to you why it's a market twin and not what makes it different. So we have had funding from DIA to progress this initiative. The aim is for Wellington to be the so-called guinea pig and to hand it on to a central government agency or another body for it to be rolled out across New Zealand. Why is Wellington doing this? Well, essentially, Wellington has 600 plus earthquake-prone buildings that all need strengthening and underground works. It has Let's Get Wellington Moving program, including a massive light rail initiative and major works in terms of water and other infrastructure. All this work requires work on the underground environment. Wellington is the RCAs, or road controlling authorities, are responsible for managing the land and the space beneath our feet. So we need to do something if we don't want to end up with a Sydney Light Rail problem where their project went overboard by $1.1 billion. Essentially what we're going to do is look at how do we create what I'll call an online library to store, share and update data on the underground environment. On the left, you'll see a map a model showing the current predicament, which is, to be quite frank, a bit of a mess, and the system doesn't function. The aim is to do something which will create one source of truth, a trusted government, whether that's a lowercase g or an uppercase G, source of information. It will be a map-based program from which all parties in the sector can obtain information about what's underneath our feet. This is a creative view of what that might look like. So if I'm in the field and I'm digging up Featherston Street or something, then I will be able to click on a map. It will show me what services are under the ground and what are the attributes and key information about that location. Why is what is the role of government in doing this rather than private enterprise? The reality is the legislation, which sits with the National Code of Practice for utility operators' access to the road corridor, sits with RCAs or road controlling authorities. Now that's partially state highway and with Waka Kotahi, partly with Kiwi Rail, and then with all of the RCAs across New Zealand. So we have the ability to require any works in the road corridors, and that includes footpaths, and any asset data that currently exists to be shared with us, and we can require them to publish that data in this new digital twin platform. What are the benefits? Well, the number one benefit is that the digger driver gets to go home at the end of the day, because if you hit a 33 kV cable or you hit a gas main, chances are you won't. So safety is the number one benefit from this initiative. Also, if you think about greater surety of accuracy of the information of what is underneath the ground, and more importantly, where it is, it means we can have greater certainty of costing of works underneath the road surface. And we're working with both Aaron Jordan and Owen Smallsfield from LINZ on this initiative. It means that we can, as our cities grow more, we want them to grow more resilient, we can identify where are the spaces for new infrastructure. And we only have to look at what happened with Cyclone Gabrielle to realise the benefit of actually getting a better understanding of what's underneath our cities and our roads and where those services are. What does it mean? It means what are the things that we see less of? Less disruption to the community, reduced contract costs, so that affects all of us in the bottom pocket in terms of taxpayer money, and it means reduced time to actually design and produce stuff. Are we the only place doing this? Well, the answer is no. In England, they are setting up a system called NUA, which stands for the National Underground Asset Register. In Scotland, they have one called Vault, which I think is a great name. And Milan have just been working with Bloomberg to establish their subsurface digital twin. I can't think that can be easy in a place which has got 2,000 plus years of history. I did ask the boss if we could go for a field trip, and he said, nice idea. Anyway, so we are leading this for New Zealand. What we've been doing is looking at who are the user groups that might need this information. So if you think about it from a LINZ perspective, all those survey marks and so forth, at the moment you have to go through before you dig to find out where they are. That's an expensive proposition. If there was one single authoritative and trusted view of all the information of what's underneath the ground, and by contextual data, we mean things like, if you think about Wellington in particular, it's got an awful lot of tram tracks and reinforced concrete and so forth, and old assets which nobody owns anymore. It would just mean that there was one source of truth that could be updated on a regular basis. This is a bit of a convoluted slide, but it shows the ecosystem of who's involved in this when you take the model to a national scale. We are aligning ourselves in this initiative to the Gemini Principles, which is the Centre for Digital Built Britain. So this is about making sure that whatever we create is sustainable and for public good in perpetuity. Our roadmap, where are we at? Well, the aim is to have a system and a platform ready for the sector to use by mid-2024 for data to go in the system. I'll talk a bit about that proof of concept in a minute. And DIA kindly gave us quite a few number of million not so long ago. One thing that a number of you in across New Zealand may have been aware of is there is a definite expansion in GPR and other survey technology to go to what's QLB level of certainty of what's underneath the ground. In Wellington, we've been using a company called Reveal. They've surveyed about 20 or 25 kilometres across our city, and we've got them to put all of that data, that contextual data, so that takes all of the underground asset owners' as-built information, and then it cross-references against the surveys that were done to look for, was an asset where the survey found it, and to confirm it's in the correct location. And where there are conflicts in terms of that data, that's an opportunity for potholing and other investigation work. So far, we've got just under 60 people participating in the trial. And what we've done is the survey work is across key corridors across our city, particularly where we've got the Golden Mile for Let's Get Wellington Moving and the MRT corridors across our city. So greater certainty about what's beneath our feet gives us greater certainty around planning, timing, cost and disruption. Where are we at with this initiative? Well, we are not going to set minimum data standards. Now, this is true for both the LINZ data cadastre system and also the new AMDS program. We are not going to set a data standard, we are going to set data requirements. By that I mean we are going to say we need to know what is the asset, how deep is the asset, where is it located in its geospatial context, who owns it, and so those key information about the location of assets under the ground. Why is this different from an above ground digital twin? Well, simply because there's concrete and road surface beneath where the asset is and where we can physically see. So, and we only get one shot to actually capture this information because you can't dig up a whole country or a whole city. We will require anyone doing work across the city to actually update their information within a certain time period. This will be a change for the sector, and we will require them to share that information. One thing about mapping what's underneath our feet is, if you think about it from a security perspective and from a safety perspective, we're working with central government on making sure that this doesn't get used, this data doesn't get used for nefarious purposes. To be clear, the information that goes into this online library, map-based library, will be federated. That means that every asset owner will retain ownership of their own information. And that's what makes this different from a normal digital twin, because there are multiple actors or multiple owners of the information feeding into the system. So we will take data from Wellington Water or from electricity or from any other provider, and we will API it into the system. It won't be a centralized system. That's why we will require each asset owner to update their as-built and asset records of location on a regular basis. What we haven't figured out, and we've had good conversations with LINZ about, is whatever we create has to be scalable across New Zealand. So is this something that we can do by buying or building or adapting in terms of that technology platform? But most importantly, we need to understand what's the legal processes and processes that sit around this to make the function work. So what can you expect from the program? This is actually from Auckland information, but it simply shows you that you'll be able to click on a location and it will give you information about that particular asset. I'm not going to run through these now, but basically these are process changes for how you put information into the system. So we want to know who owns it, some information about the utility and some information about the specific object. We will have mandatory fields, conditional fields and optional fields. So an example might be, if it's a gas main, that what is the information about working around that gas main? We're going to use the muddy principles for the attributes for the assets. This is an example of what it might be for an electricity cable. So you can see the object ID, its geospatial location, what type of asset it is, and how to contact them. So on Christmas Eve, if something goes pop, what it means is a contractor can go in there and have access to information 365 days a year, 24/7. It's not held, as it currently is, in multiple sources of information in files for consultants and so forth. What is our expectation of the sector? We've had a really good response from the sector. We're going to need them to work with us about where are they at on their digitisation journey in terms of their asset information. And we need them to work with us on getting ready to put their information in the new system. One point I want to make is you don't create 150 years worth of putting stuff underneath the ground and having unreliable asset information and then expect that a new system will be perfect from day one. It is going to take time to improve the quality of the information in the system. And we're going to take a modular and phased approach as to how do we do that. These are just some of the awesome people who've worked with us on the project to date. And we've had a whole cross section across the sector, both in Wellington and across New Zealand. Finally, what we're looking at is if we're going to create a system, how can it be rolled out across New Zealand? Who should own it and who should operate it? Now, is that something that Waka Kotahi would naturally take, or the Infrastructure Commission, or LINZ, or a mixture of those? That's or a charitable trust or something. We need to work through what does that model look like, and we're working with ministers and other parties on that. And then finally, how do we keep the data current, and what are the processes for doing that? And our aim throughout this project is to start small, get the basics right, and then build from there. And those are our contact details. So I'm happy to share that presentation. I've sent a copy to Ben. So if you would like a copy of that, we're happy to for that to be shared, and we're happy to talk to anyone who's got any questions. And I'm conscious that I'm pretty much out of time, so I'm happy for people to contact me later or whatever works.
Thanks very much, Denise. That was fantastic. Yeah, as you mentioned, thanks for sharing that slide pack, and I'll include that in the whole pack that I send out to everyone after, or make available after the meeting. Yeah, if any, I know Denise, you've got to shoot off, but if there's any question, maybe one quick question, if there's something pressing, otherwise pop it in the chat and we'll record it, or there's the email address in the slide pack. Yeah, so that might be that. Okay, next up we have Deb Burgess from Ministry for Environment talking to Lucas Land Use Map. Hi, Deb.
Hello, hello. I'll try and share my screen and see if this works. How's that looking?
Looking good to me.
You can see some slides. Yeah, excellent. That's a good start. Okay, well, so yes, I'm Deb Burgess from the carbon sequestration team at the Ministry for the Environment. That used to be called the Locus team, and it is the team responsible for looking after one sector of our international greenhouse gas reporting. And when Ben mentioned that the topic or the theme for this meeting was going to be land use, it kind of pricked my conscience. I thought, yeah, we have a land use map and I haven't talked about it for ages, and maybe it's time just to explain a little bit about what this is and more to the point what it isn't. And the other thing that just came across my desk was looking at the stats from our MFE data service and realising that this data set is still far and away the most downloaded data set on our service, even given that the most recent version of it is a 2016 data set. So I thought, okay, there's clearly a bit of a user community out there, and so I thought it was perhaps time for an update in terms of what's going on with this data. So this morning, let me just see if I can make this advance. Here we go. There we go. So I thought I'd just cover off what the Locus Land Use Map is and what it isn't, or in fact just starting with why do we have it in the first place? What is it? How do we go about making it, and where to next in terms of the roadmap for this work? So the backstory to this is that way back when New Zealand signed up to the United Nations Framework Convention on Climate Change and then the Kyoto Protocol, And now the Paris Agreement. So these are international agreements where the country has committed to certain targets in terms of our greenhouse gas reductions. And each of these agreements comes with reporting and accounting requirements. And there's a difference there. The reporting requirements are, please tell us your information. The accounting requirements, at least under the Kyoto Protocol, came with a cost in terms of if you did or didn't meet the targets that you committed to. So as I just mentioned that, then one of the sectors goes by this convoluted name LULUCF, which stands for land use change and forestry. And so that's the area that we work in, looking at how do we measure all the emissions and removals associated with that sector for everything that happens in terms of land use change across New Zealand. And yeah, as I say, we have to account for these emissions. Mainly it's about land use change, but it's also about forest being forest, just growing. That is another key part of what we're trying to measure. So when New Zealand was faced with needing to do this reporting, we had to first sort of look at, okay, what's our national circumstance? What have we already got in the way of data, and how can we build a system that's going to enable us to do this quite ambitious measurement and monitoring job? So we were faced with the fact that we had no spatial forest inventory. So a lot of countries, particularly EU countries, developed countries, already have a lot of detailed mapping of their forests, and that puts them in a good position to do this type of reporting and accounting. But in New Zealand, we didn't have that. We also had significant areas of what's called post-89 forest. This is forest planted after 31 December 1989. And this is forest for which we can get credit for its growth in our inventory. Anything that's planted before that time is actually part of our baseline, and we don't get any credit for its growth, but we still have to pay the cost associated with its deforestation. So anyway, we had a lot of planting going on in the early 90s, and this meant that New Zealand was in a position to effectively gain quite a bit of credit for the removals associated with the growth in that forest. And but we did need a credible system for showing that that forest did in fact exist and continue to exist and grow. So this is one of the things that factored into the decision that we were going to need a mapping solution. The other thing that that New Zealand had is limited administrative data. A lot of countries have really quite good land use information because of subsidy systems and things like that, or other land use information associated with their property data, but we really didn't have enough of that kind of data for us to be able to hook into another system to get our land use information on the kind of regular basis that we needed it. And then in terms of our geography, steep terrain and persistent cloud cover were just factors that we had to consider in developing a solution. So the other thing that we had to consider is what's the UN actually saying about what they needed in terms of the reporting requirements. And these were some of the principles. We needed to at least consider 6 land use categories: forest land, grassland, cropland, wetlands, settlement, and other land. Bit of a catch-all for everything that's not in the first 5. We had to develop a system that was compliant with these IPCC principles of being transparent, accurate, consistent, complete, and comparable. And this is the principles that we reviewed on annually. They take these principles very seriously, and they really do look at our entire system to make sure that it's up to standard across those different principles. One of the things and the guidance that's provided is that, they do provide flexibility for countries to develop different solutions. So you don't actually have to do wall-to-wall mapping. As I said, you can use administrative data. You can actually sample the whole country across a grid and look at land use change at grid locations. But because we were a signatory to the Kyoto Protocol, one of the requirements of that is you do actually have to map deforestation to at least a hectare or a finer scale. So we were in a situation where a mapping solution was really what we were going to need. And there was some co-benefits, I suppose, to actually going down the mapping route. So looking at the map itself, what is it? Well, it's 12 land use classes, and they're slightly unusual classes, which I'll come to in a minute. It covers the mainland of New Zealand and the Chatham Islands. We've got this minimum mapping unit of a hectare and a minimum width of 30 metres, so it's quite a broad scale map. It's kind of analogous to the sort of the detail of land cover database. So far we have 4 mapping dates, 1990, 2008, 2012 and 2016, and those dates look a bit weird, but they align to the beginning and end of a certain key reporting periods. And what we actually do report on each year is not just land use change across those dates, but annual land use change. So there's interpolation and extrapolation processes that go on to get us from 4 maps to annual data from 1990 right through to whatever the reporting year is. So if we look at the IPCC land use categories and then how we've divided them up, you can see that we've added a bit, and that's a bit of granularity to make our system work a bit easier in terms of splitting out those forests into the key before and after that baseline point of 1990. So we can clearly see in the map those forests which are part of our baseline and those forests which are contributing to our removals. We split out annual and perennial cropland. The grasslands are interesting, high and low producing grassland, and we added this weirdo one, grassland with woody biomass, which was just covering off the fact that we do have quite a lot of shrub species through our grazing land, and it's got a reasonable woody content, but it's often in a grazing use, if you like, and so we tried to capture that in its own special category. If you're thinking about this in terms of a normal land use map, and in grazing land, you would be expecting to see things like sheep and beef and dairy and that kind of thing. For the purposes of our greenhouse gas reporting, that's not part of what we are doing. We are really considering it's just about the biomass, the stuff that's growing on the ground, the soil carbon. The whole agriculture is another sector. So everything to do with animals and that happens in a completely different team at MPI. And so we are very much focused just on the grass itself. But so this is where, maybe somebody coming to this Lucas Land Use Map cold might be thinking this is a very weird classification for a land use map. And certainly we are now having this wider conversation of is there another more comprehensive national land use map that New Zealand actually needs, which covers off things you'd expect to see in a national land use map, which would include a more of a activity-based subdivision of grassland and possibly some more detail in terms of the urban areas. But that's an open question at the moment. In terms of what we've called forest land, that's not just tree cover, but it includes all the land that's associated with forestry use. So it includes harvested land, it includes skid sites and forestry roads and all that kind of thing. So I think the key distinction for this map is it is a land use map rather than a land cover map. And the whole system is designed to do carbon measurements on the same sort of format. So we have a plot network that measures the carbon in the forests, and if the plot happens to land in a bit of bare ground or a road, we measure the very minimal carbon in that area, and the whole thing comes out in the wash on a national scale. So the other thing that's quite specific to this map is what we call a forest. So this is a definition that we've elected in our reporting. We have some flexibility in this. So we say it's got to be at least 30% ground cover, and it will reach 5 metres in height at maturity. And this is the other tricky thing, is that it's not necessarily 5 metres at the moment, but we're believing that all other things being equal with the current use, current climate, etc., it will grow to that 5 metres in height and maturity, which means that we've got shrubby type cover that could be mapped as forest, because it's in this retired context, or it's in some kind of context where we can see it growing to 5 metres within that time frame. We've got the classes are natural forest and planted forest, and they are not Indigenous forest and exotic forest. And so that's another weirdo feature of the map. So natural forest means it got there by itself. So self-seeded, so therefore we've got the wilding pines in with the Indigenous species. And planted forest means that human intervention was involved. Therefore, it's all our exotic plantations. It could potentially be Indigenous plantings, and we're starting to see Manuka planting going in. If theoretically somebody put in...
No problem. I forgot to tell you, because I did a bring up on it, that your friend Nick...
Oh. Sorry, we've lost you there. No?
I think you're good to go, Deb. Carry on.
Okay, all right, I'll carry on. Yeah, so Indigenous planting, theoretically, and as I say, any kind of exotics go in the planted forest category. And then we've got this pre-90, post-89 split. The pre-90 planted forest is on any land that was forested at 1990, not necessarily that same forest. So there's another, we can have a situation of a land which is forested at 1990, turns into grassland somewhere in 2008, goes back to forest at 2012. We'll call that a pre-90 planted forest. So it's a bit of a, it's this strange time series thing, but it's recognizing that new forest is still a forest on 1990 forested land. And yet post-89 forest, obviously on land that was not forested in 1990. Okay, so how do we go about making these maps? It's based on satellite imagery, multispectral 10-metre resolution, most recently Sentinel imagery. And from one map to the next, there's a change detection process that is completed within forest land and non-forest land. That's done by Manaaki Whenua. And we also incorporate the forestry scheme mapping from MPI into that. That's particularly helpful because seeing new forest going into the ground, it doesn't show up in satellite imagery for about 3 or 4 years. So having other data sets to bring to the party and say, okay, we know there's a forest gone in there, we can't quite see it in this imagery yet, but you know, it will turn up in due course. We make these maps every 4 or 5 years, and in between that time, we're continuously doing deforestation mapping. Because of having that requirement to map that spatially to 1 hectare, we need to have that data annually. So this is the general picture of how this mapping program has worked in the past. The CP1 that refers to Commitment Period 1 of the Kyoto Protocol, and Commitment Period 2 that ran from 2013 to 2020. And now we're in this Paris era. I need to update this picture to show NDC1, which is the period from 2020 to 2030, which is the first Paris Commitment Period. So we are making the 2020 LUM at the moment, and there will be a 2025 one, and then one at the end of NDC1 in 2030. So in terms of the overall process, and there's one more piece of the puzzle, and this is this grassland piece, and this is where the property data or the valuation data comes into the mix. What we found, the reviewers were sort of asking questions about our mapping of grassland. And to be fair, we hadn't paid a lot of attention to the mapping of grassland, where it was not the exciting bit of a carbon equation. But they were saying, look, you know, there's lots of evidence that intensification of grassland is occurring in New Zealand. We would be expecting to see a shift from low producing grassland to high producing grassland. And we said, yes, you're probably right. It's very hard to map that from satellite imagery. The kind of greenness in a single image is more to do with whether it rained last week than, you know, whether this is genuinely high producing grassland. So we thought, okay, we definitely need another way of identifying these areas of high producing grassland. So Manaaki Whenua had been doing some work called the Innovative Data Analysis Project, which uses a fuzzy logic and a sort of a mashing up approach to combine lots of different data sets and create, this is a picture, a degrees of truth raster. And it is the mashup of all these input data sets to determine what is the likelihood that a given area is high producing grassland at a given date. And the other thing that we were able to do as part of this process is, you could say, we try to beat a subclassification of grassland, saying, well, what can we achieve with this method in terms of giving us a bit more of an insight of what kind of use is going on grassland. And so we went with dairy, non-dairy and ungrazed grassland as our first kind of toe in the water of getting more of an insight of what's going on the grazing land. So these are all the input data sets that went into that almighty mashup, and it's probably a bit hard to read on this picture what we've got, but we've got slope, we've got land use capability, growing degree days, the rating land use. So this was back in the days when we were buying this data off CoreLogic, but it's the valuation data. And so we've got the actual and also the potential. So that's the highest and best use out of the valuation data. Then we've got the irrigation mapping that MFE did a few years ago. We've got the LINZ water deficit. I've got agribase in brackets because we couldn't actually use agribase given the license constraints. And so what we actually did is we put it in, we tried it, we took it out, we made sure that there was next to no difference taking it out and found that that was the case. And so we were happily able to cut ourselves adrift from that license problem. Then we've got the protected areas layer from Landcare. We've got the previous mapping of high producing grassland from the locus lum, LCDBs, high producing grassland, and what's that last one? Soil droughtiness. So those were our input layers, and as I say, if I just go back, the final output is this degree of truth. And so we then thresholded that and said, okay, that's our position at 2016 in terms of high and low producing grassland, and we're hoping to rerun a similar method in our 2020 map and see kind of what's changed based on. And really, I mean, the main input that's going to have changed out of that will be evaluation data. So it will be driving our insight into where there might be new high producing grassland areas. I think that's the two in the middle there. And finally, in terms of what's next, as I say, we're currently making a 2020 land use map, and we're incorporating some changes to the data schema on that so that we can theoretically capture change between any land uses. We're striking problems like repeated deforestation now that we've got quite a series of maps, and so this led to the need to be able to capture events in a sequence that happen more than once. We have used deep learning methods in parallel to our sort of a classical change detection process to see if we can find some areas that have never been mapped correctly. One of the problems with these kind of change on change maps is that if you got it wrong in the first place and you never trigger any kind of change, you never get it right. So we've said, okay, let's just do a blue skies look to see if there's any particularly exotic forest that we've never mapped correctly. And that's been quite interesting to see what that kind of approach is capable of now. And then also this idea of finding crop to grass conversion, which is something that we know that's happening. And again, the guys at Manaaki Whenua have done a fantastic job of adapting some multi-temporal techniques to find areas that we have mapped as annual cropland, but which are really not showing that yo-yoing from soil to vegetation that you would expect to see in an annual cropping area. They are looking quite stable with a solid signal of reasonably high NDVI, which you would say is more consistent with the grasslands. So that's one of the new techniques that we're playing with. So just to mention that the LUM itself is available on our data service, 2 layers, the New Zealand mainland and the Chatham Islands. There's also a forest clearing layer, which I haven't talked much about, but this is a kind of a byproduct of our deforestation tracking. And that, I think, has some potential, untapped potential possibly, and that it's quite a long time series now showing where all the harvesting and clearing, forest clearing is occurring across the whole country. Through to 2020 at this point. And yep, there's a few more useful links to things associated with the program. So I think that's me. Sorry, I have no idea how that's gone for time.
Fantastic. Thanks, Deb. No, we're all good for time. Yeah, were there any questions for Deb? There's nothing's come through the chat yet, Deb. Oh, Carl's got a hand up. Go, Carl.
Yeah, hi, Deb. Does Lucas get audited by the international community?
Yeah, each year we either have a centralised review in Bonn, or occasionally a team actually comes to New Zealand and spends a week going over the books and asking tricky questions. So yeah.
Cool. Well, thanks, Carl, for that question. Otherwise, silence is golden, and we'll let Deb turn her camera off, and we'll move the spotlight to Richard Law from Manaaki Whenua, talking to land use classification using a discrete global grid system. Just looking for Richard pop up on screen.
My camera is not working. But can you see my screen otherwise?
Yep, I can see a screen.
I can see, oh, it's the end of my presentation, not the beginning, sorry. Great, title page, we're all good
Looking
to go?
good, yep.
Cool. So my name is Richard Law, I'm a GIS analyst at Manaaki Whenua Land Care Research based in Palmerston North. This is actually a rehash of a presentation I gave in August last year at GeoCart. So if anyone was at that and saw me present there, this is literally the same slides, which also means that it's a little bit not that fresh in my mind and was also made with a slightly different audience in mind. So bear with me, but I hope this should be a good follow on from Deb's presentation actually, because some of the points you mentioned I'll touch on again. So land use classification using a discrete global grid system, or a DGGS. I'll explain what those things are as we go through. To give a brief overview, I'll talk about the task of land use classification generally, and I'll narrow in one particular problem among many, which is the problem of integrating raster and vector information. And I'll particularly mention how a discrete global grid system can improve that situation. And I'll end up giving 2 examples of land use classifications we've made with discrete global grid systems. One that was current 9 months ago and one that's current now. So the task of land use classification in general, and hopefully this came through from Deb's talk as well, is fundamentally it requires integration of multiple sources of information. Sometimes a small number of things, sometimes 20, 30, 40, 50 different inputs. Depending on the complexity of your classification, or perhaps how confident you need to be, and so on. GIS data obviously comes in 2 primary data models: the vector model, geometries, topologies, coverages. There's various ways you can slice that, but primarily geometric objects. And on the other side, raster data in various grids and resolutions and time series and so on. So just taking a concrete example to narrow this down, Sheep and Beef New Zealand has I believe it's 8 classes they use to describe sheep and beef farms. And those are based on various characteristics of those farms, and they actually publish information about farms according to that typology. So you can get things like average revenues of specific types of sheep and beef farms. One example from them is what they call a North Island hard hill country farm, as opposed to, say, a South Island high country farm or something else. And they define this, or perhaps they describe this rather, as a steep hill country or low fertility soil farm, where most farms carry 6 to 10 stock units per hectare. And they continue, while some stock are finished, a significant proportion are sold in store condition. So if we break this down into how you might approach this from a GIS perspective in terms of assembling data to try to identify which bits of land, however you define that, meet this criteria. One approach might be to work out, first of all, where the farms are. So the boundaries of the farms, you might look at the district valuation roll, the LINZ property data stuff that's going on is looking quite promising as well. So you might also get some information from, say, Agribase or some other source of farm information from councils, perhaps. And they could tell you things like the topology of the farm, perhaps breeds, what animals are there based on consenting information, or perhaps just direct surveys. If you pay Agribase lots of money, you can get information about stocking rates. You won't get information very easily about body conditions. The second part of the statement here. I don't think anybody's collecting this information that I'm aware of. If they are, they're not sharing it. So already we're sort of limited to the first half of this definition, but we'll continue anyway. You might integrate land cover information, say from LCDB, to limit your analysis to improved grassland, or perhaps from LUM. You do something like pedological information from, say, SMAP to try identify low fertility soils, however that's defined. And finally, you might use raster information, so maybe a geomorpho, that word, approach to identify steep hill country as opposed to flatlands, tablelands, whatever it is that is not steep hill country. And the challenge is to integrate not just within one data model, the vector model, but also across raster and vector data models to come up with a reasonable stab at identifying land that meets this criteria. So if you draw those 5 things on a map, let's say you've got the district valuation role, the land use category in various shades of grey, farm boundaries from Agribase in various colours. They also include information about stock density, although its stock density could be calculated across the entire farm, not necessarily the effective land of the farm. Say, for instance, many farms have forestry blocks as well as areas for grazing. So you can't necessarily do a naive stock density calculation. We can also throw in LCDB land cover that's just shown in black lines without any identification of classes, but this is obviously a settlement, and over here is various farms. The land environments of New Zealand level 4 segmentation includes information about acid-soluble phosphorus. You might use that as a proxy for soil fertility. And finally, in the raster space, from the same source, we can get a 20-metre raster grid of slope in 1 degree increments, I believe. So throw those 5 things on top and you can start to see some of the issues. First of all, you can see sort of strange boundary effects between conflicting sources of information. For instance, this, you can see my mouse, is that coming through? So this boundary here of a farm looks like it's attempting to approximate the same boundary that's identified in LCDB, but they're coming from different scales, so they don't quite align. Similarly up here as well. And you can imagine that problem multiplied as you incorporate more and more data for boundaries of all types of features, coastlines, forests, farms, rivers, and so on. We also need to think in terms of a system of land use information rather than a land use map. So we talk about, people say, oh, we need a land use map of New Zealand. Well, a land use map for what? We just saw a presentation on the Lucas LUM, that's a land use map for carbon accounting. at Manaaki Whenua, we have an econometric land use model called NZ Farm that is capable of doing projecting land use under various scenarios and environmental constraints and so on. That has a particular vocabulary that needs to be used. It's got about 12 classes that can be assigned, and that's based on available economic information. Someone else just might want a general purpose map, or you might want to align with a particular international standard or what's used in another country. So for instance, in Australia, they use the Australian Land Use and Management Classification. They're up to version 8. You could opt to align to that, for example. We also need to continuously update them, as we see in LUM. Obviously, as soon as a map is published, it's out of date. And we therefore should consider an information system, some way of producing land use maps based on a systematic approach, using APIs to obtain the most up-to-date information from authoritative sources and accounting for things like different scales and different confidences and different dates and provenances. But I do want to narrow down the problem not to one of classification, vocabulary, or ontology, but a more technical issue of how you actually bridge the raster vector divide in terms of input data. So if you were to produce a land use map that, say, met that definition of North Island hard hill country farms, one way to do it will be to convert everything into raster space, and that's what was done with that innovative data analysis program for grassland mapping, I believe. That wasn't me personally who was involved in that, but you convert everything to effectively a common raster grid and do raster algebra. That's fine, that's fast, but there are limitations of that, which we'll get into. Alternatively, you could convert everything into vector, so you could segment rasters according to thresholds, produce contours, and then overlay those with your other vector information. And again, there are problems with that we'll get into in a moment. And a third approach could be to sort of do a zonal statistics. So you could imagine, say, calculate the average slope for farms as defined in Agribase. So conversion to raster, if you convert your vector data to raster in order to produce a land use map, there are some limitations of that. And one of those is losing its information about its native scale. So LCDB is published at a 1 to 50,000 scale. If you rasterize that to a 5-meter grid, you lost some information about the scale that it was actually published at. You also lose information about the sort of semantic meaning of vector objects. So a road, for instance, which has direction, which has a name, which can overlap things, or a farm boundary, which has an owner and abuts something else. You know, those are geographic entities, but when you rasterize those, it's hard to retain that kind of information about them. You also assume that everything you're dealing with effectively is a coverage, because you can't easily represent overlapping features in raster data, at least not as easily as you can with the vector data model, which is very easy to do. You lose its rich attribute data, so it's easy to work with attribute data in vector space. Not impossible in raster space. Raster attribute tables are one possibility, but it's difficult to work with those compared to working in vector space. And finally, there's also no authoritative grid. So you can choose a common raster grid for your land use map, but it's not necessarily the same grid that anybody else is using, which can be a problem if you were to try and publish your data and integrate it with somebody else's. Alternatively, if you converted all your information to vector to produce your land use map, you then end up in a situation we saw earlier with many conflicting boundaries of entities. So if you overlap LCDB rivers with, say, some other source of river information from LINZ, the boundaries aren't going to align. Fundamentally, they're trying to map the same thing. Those boundaries may as well align, but they don't actually align. So when you do a naive intersection of those two things, what you end up doing is producing an absolute explosion of small geometric artifacts. We call them sliver polygons. And the more and more things you integrate, the more those slivers just continue to explode. So I referred to that in the past as sliver polygon hell. It's very difficult to deal with that problem. Alternatively, if you were to do zonal statistics, so you're to basically sort of republish your raster information according to some common spatial unit, say a parcel or a farm boundary or a watershed, and calculate the average slope across that area. That's one approach you can do. However, that zonal statistics are typically expensive to calculate. They are certainly in the default implementations in QGIS and ArcGIS. They also don't account for partially covering polygons. So if you've got, particularly if you've got a coarse raster data and you want to calculate the average slope, say across an area, pixels are either in or out of that calculation in most implementations. So you don't say get 30% of this pixels value influencing the unit area summary value, which can be a problem. It also requires an upfront decision on the appropriate spatial unit. So you have to decide that we're going to index this rastered information as a parcel or as a watershed. And once you've chosen that unit, you're effectively stuck with that. It's not an adaptive system-based approach where you might adapt your spatial unit of analysis according to your needs. So where does a DGGS fit in? Well, I obviously need to define what that is. So this is the technical definition according to the OGC specification, which I'll read and then I'll break down into a simpler takeaway. So a discrete global grid system is a spatial reference system that uses a hierarchical tessellation of cells to partition and address the globe. DGGSs are characterized by the properties of their cell structure, geoencoding, quantization strategy, and associated mathematical functions. It's a whole lot of words that don't really mean too much. So let's break it down. It's a spatial data structure, or perhaps a data model, I prefer to call it, based on hierarchically nested subdivisions of Platonic solids. So we're thinking things like hexagons, triangles, squares. They're composed of discrete cells, a bit like a vector object, more like a coverage. They're global in coverage or scope, and they're used to quantize both vector and raster data into a common hierarchical grid system, which is a bit like a raster. So therefore we can perhaps think of it, and I think this is the best way to think about it. You take nothing else away from this, this is what a DGGS is, a hybrid data structure that retains properties of both vector and raster data structures while presenting additional benefits. It's worth emphasizing at this point that a DGGS is not a data format. It is a data model, so I can't give you a DGGS file per se. And then, so when we convert vector and raster data to DGGS, we call that operation indexing. So working out essentially which cells of our grid that covers the entire globe should be used to represent vector objects. So in the black lines here, we've got some vector data. I believe it's LCDB, I'm not sure. And then in the green and the purple, we have cells of a particular DGGS. In this case, it's the H3 DGGS produced by Uber. And I've identified in purple the cells that are used to represent this particular shape. Each of these cells it's a hexagon. It's a hexagon-based DGGS. It could be based on triangles or squares if it was a different DGGS. And each one of these, in reality, is a 64-bit integer ID. So each one of these is a stable identifier that's common across everybody who uses the same DGGS. You run an algorithm on features called polyfilling, where you use a library to compute which cells at a particular maximum resolution fit into the shape. Then you retain that essentially that list of IDs, and that represents your shape, the geometry of your shape, in lieu of the original vertices. Now, what it looks a bit funny at this point. We kind of see all these funny gaps between things. It doesn't quite match up to the edges. I think one thing that people find a bit confronting is that with this representation is that issue. But it's worth remembering that although this is a sharp vector object, you can download this from Malloris and you get a nice little sharp boundary between what is and what isn't this class. This is a 1 to 50,000 scale map product. The vertices in this object, however, are recorded to 12, 15 decimal places, but no one has actually gone out to the edge of a forest or a town and measured the point of change to within a nanometer. 10 meters would be a generous sort of approximation of the real boundary of these things. So when we approximate the shape with these hexagons, although it looks kind of funny, it is actually a better declaration of the proper precision of this thing. And we can imagine that if we knew that this was a much more precise definition of a boundary, perhaps a legal parcel boundary, we might use a higher resolution DGGS to represent that shape than we would for something that is much more vague. On the raster space, I think this is perhaps a bit more of a direct translation. We can take, in this case, it's that slope map we saw before, 1 degree increments, so 0, flat, 1 degree, starting to slope and increasing into the hills here. And we effectively just map pixels to DGGS cells, and then we can represent cells where at the highest resolution that we picked, which should approximate the raster resolution, where all values are the same, we can just store one reference that represents everything below it, which can save on disk space. In the same way that a compressed raster isn't actually storing every single cell, it's restoring, effectively stores a number and then how many more of those repeat. Now, what are the benefits of doing this? Once everything's in the same reference, you can rapidly join across disparate data sets. So for instance, we can say here, we know the slope of cell 1, 2, 3, and we can then ask the same system for what is the land cover of cell 1, 2, 3. And so by indexing that reference, we can match across those data sets without doing any kind of geometric computation apart from the initial indexing. That allows us to rapidly join across multiple data sets and to bring in new data very easily into an existing classification system. It allows us to be precise about explicit about the precision at which data is actually recorded, and allows us to do geospatial operations with discrete mathematics, so set theory, rather than using geometric operations, which is much more computationally expensive. So if you imagine you've got an area of forest and a vector overlay, and you've got a parcel, and you want to say which parts of this parcel are forested. Traditionally, you'd get your two objects, and you'd use the computer to calculate the intersection and record the new sub shape of those things. Once you've got things in DGGS, you effectively say this object's represented by cells 10, 11, and 15. This other object is represented by cells 10, 9, and 7. And then to work out if those two things overlap, you just say, are any of the numbers on the left-hand side the same as the numbers on the right-hand side? If so, they intersect. That's a very fast thing for a computer to do compared to doing geometric math. It also means that it's a lot easier to use in databases and data frames. You can begin to break away from dependency on difficult to install geographic libraries like GDAL and simply fall back to set theory, using numbers to intersect things rather than having to understand coordinate reference systems and so on. So here's an example of how you might do this in practice. And apologies, this is a bit technical. It's showing some SQL, but I'll break this down in a way that's easy to understand. So we want to join two things together: parcels originally from a vector source of information, and slope originally from a raster source of information. But both of these things are implicitly have been converted to a particular DGGS, the H3 DGGS. We're asking the database to select everything we have about parcels, everything we have about slope, which doesn't really make sense, but perhaps maybe you think of that as a multispectral raster rather than a slope, and also compute something on the fly. So some property of A multiplied by some property of B, and label that. Then this is where we get interesting. So this is where we identify a spatial relationship to join those two things together. We simply take the H3 cells from the parcels and the H3 cells from the slope and do this particular operation here, which is, do they intersect? You could do, are they equal, which would be which would work only if they're at the same resolution, whereas intersection works across resolution. So if we were to index this at a lower resolution than this one, this would still allow us to join across those data sets. Then we can adaptively filter on the fly, and this is where you might start to define some logic for classifying land use. So we can say where slope is between 10 and 15, and we only want parcels that aren't hydro parcels, and that would give us a particular output. You can imagine as you get more and more complicated and do a real land use classification, this would need to expand and become a bit harder to understand. But the fundamental relationship is quite simple. It's just this intersection of H3 DGGS cells. So I can give you some examples of where we've used this in practice. So a couple of years ago, we did a land use map for Horizons Regional Council. And then sorry, no, that's wrong. This is actually a classification. It will be a classification that was produced for use by NZ Farm, our economic model. Let's just show some context. This is from OpenStreetMap, a map of Blenheim, and the output of this map. And we can see in the legend all the classes that were defined, including, as we saw before, the North Island Hard Hill Country Farm. So this is the South Island, obviously, so this is using the South Island breakdown. We also have 5 dairy systems defined by Dairy NZ, and some other classes that aren't in as greater detail. And obviously you can see here my point that land use maps are made for particular purposes. This simply uses built environment land use, and that's directly from LCDB with no other integration of other information. But these other classes are expanded beyond the classifications that we use in any inputs. And what's nice is that we can scale this, and this is quite a coarse resolution. Admittedly, we can go higher than this, but we can scale this very, very quickly to a much greater scale. So this is the entire country, including offshore islands, that we produce this map for. And one of the benefits of DGGS is that when we produce an actual national classification, we can include the Chatham Islands without any additional difficulties. There's no issues with anti-meridians, which is quite a nice feature if you've ever had to deal with that problem before. That's sort of, I do have one more example I can show you.
Oh, Richard, that's okay.
Sure, okay.
Sorry to cut you off. No, that's been really great to see those examples, and I think that's given everyone a really great idea for the time being, but we are hard up on time.
Cool, no worries.
So maybe just maybe you can flick that to me and I can include it in the slide pack to send out another example along with those ones already. Sweet. And in terms of comments, there's just one quick question from Jared. Presumably you could use this approach to look at the percentage area of each ID. Can you quickly just...
Yeah, but you can, so that's basically what I was going to show in the next example, was that you could you can effectively pick your spatial units, and we do things, we produce like parcel scale classifications where we look at, say, the majority class of a parcel. And so you can slice that however you want. If you want to overlay watershed IDs instead of parcel IDs, that's perfectly easy as well.
Terrific. Thanks again, Richard. And thanks, Jared, for that question. Any other questions, feel free to flick them through to us. But for the time being, we're going to move on to talk to the ratings valuation rules review. Here's Andrew, beaming in from Christchurch. Did you want me to share from my end?
Oh, yes, please, Ben. Can you hear me okay?
Yeah. Yes, we can hear you.
That'd be great. Yeah, if you can share. And I'm on just the laptop. I'll be looking at my notes. So I'll just let you know when we're moving between slides.
Perfect. Just let me know when it pops up. I want to go from. Hang on, just need to get the right slide.
Right.
There, should be looking at your title slide there.
Just buffering for me. Oh, here we go. Yep, all good to go. Cool. Well, kia ora koutou. My name's Andrew Freeth. I work for Strategy, Policy and Design group within LINZ, and I've been helping out the Office of the Valuer General with a project to review the rating valuation rules. I just wanted to start by talking about the rules. I'm going to tell you about the objectives of the review and the approach we're taking to the project and our timelines. I hope it's of interest, and be happy to take some questions at the end, or for you to get in touch with me afterwards if anything's of particular interest that you want to discuss. So the rules are made by the Valuer General. They're secondary legislation, so they've been delegated to the Valuer General. They regulate the rating valuation process, so they're what valuers need to follow when they're doing rating valuations that the councils then use for rating for rates. So they relate to the rating valuation process, and also the maintenance and content of district valuation roles. So the current set took effect, it was in 2008. There was a few minor changes made in 2010, but in general, most of the rules have been in place since 2008. So now getting on to 15 years old, so in need of a review and some changes. A lot's changed in the digital space, as you'll be well aware, in that time, and stuff's changed within the valuation practice. So moving on to the next slide, these are our objectives for the review. So we want to enable the better use of technology by valuers, by councils, by the Office of the Valuer General, just to make the whole process more effective and efficient. We want to improve the data quality and also the transferability. So when a valuer council changes valuer, the ease of transferability of all that data to a new provider. Currently, with the audit process, we get a flat audit file, flat pipe delimited file that comes through every 3 years for the Valuer General to do his audit process. And there's better ways that we think that we can do that now. So we're looking at moving to some kind of relational tables or relational structure for the data. So we're looking at the whole data schema of the DVR, district valuation role data. That's one of the areas we're looking at, and perhaps bringing in some more prescriptive rules about the data schema. Also, like the content of the DVR, looking at what we think should be collected now, and what maybe doesn't need to be collected anymore. Improving data quality, getting rid of any errors. Text entry can lead to some errors or inconsistencies in the data. So that kind of focus areas. When we get rid of that audit file, if we move away from that, we'll remove the fixed data field lengths. So that can sort of cause problems with the Office of the Valuer General and connected property data for when we want to use that data, we want to connect it to things. And if we've got fixed field lengths, the data can get truncated. So that's another focus. So in that third objective there is, it's a secondary benefit. So the rules are focused around rating valuations, but if we can improve the data, then we can have better connected property data. The next slide, we are, the approach to the review is, instead of looking at the whole review current document and undertaking a review of all the sections, we're doing it topic by topic. And we're starting off with the district valuation role, data schema and content. And I've already talked about a couple of things that we're focused on there. Before we undertook the work, there's been some reporting that's been commissioned internally at LINZ. We had a couple of reports from Valstars. One was a research report, looked at issues that might want to be addressed within a rules review. And then we had a second report that started to unpick those issues a bit more. We also undertook a regulatory system assessment. So we looked at the efficiency and effectiveness of the regulatory system as a whole, and some recommendations came out of that, and in particular to do this review, but also stuff that we might want to think about in the review. And so when we started the process, and what we've been doing recently is we ran some workshops with the Office of the Valuer General, and that was just to gather what's been done before, what are the identified pain points, what's some opportunities, and so we've got that documented and priorities as well. And we've sort of fed that into some proposals. So we're coming up with some proposals. We're just working on an engagement document at the moment, and we're looking to do some targeted consultation with councils and valuation service providers very soon. So we're just going to start off with some targeted consultation, test these proposals out, ask questions of what the stakeholders think. Would these proposals work? Would they cost a lot? Is there any reason that they might not work? Are there any other ideas? And then bring that back. When we got that feedback, we'll gather it up and look at the proposals. Do they need amending? And this will lead us into drafting a new set of rules, which will then go through a formal consultation process. So the Rating Valuation Act sets out a formal consultation process. And when we've got all our proposals for changes across all the topics we're looking at in the rules, we will then go out for a formal consultation and give every stakeholder that has an interest a reasonable amount of time to make a submission. I thought I'd just mention that with the DVR, and many might be aware of this, but it's the most complete national data set that can ascribe the attributes of both land and buildings on a property. So very valuable data. And on to the next slide. So once we've completed the DVR proposals around the data schema and the content, we're going to move on to the other topics for review. Other things that we've identified to give a review are the objections process, district valuation role maintenance, general revaluation process, and also the overall structure and usability of the rules. So, are they user friendly? Is the structure helpful for people that use it in the end? In terms of our timeline, our aim is to begin the formal consultation on a new set of rules next year, 2024. So that's what we're working towards. I think that's about all I wanted to say, but happy to take any questions. And as I said, happy to, if anyone wants to get in touch one-on-one to give their thoughts on the review, or that can be arranged too. So happy to take any questions anyone's got.
Thanks, Andrew. That was I thought that was a pretty good summary of what is entailed there for the review. There are some questions coming through the chat. I just see Mike Jard has already answered one from Jared, but then Richard Law asks, is there a controlled vocabulary for improvements description in the DVR?
Yeah, we did cover that off on the workshops, and I understand that it's meant to be large improvements, isn't it? We did take some notes from the people from the OVG that were in the meeting, and it was identified that there needs to be more description around what is called for there, and perhaps what that data could then be used for. So it's a part of the rules that we're looking at, and we will be coming out with some proposals for that.
Sweet. And then Mariona asks, are you going to also include other government agencies that use DVR for purposes other than tax in your targeted consultation? So
yes, we are.
Yeah.
So very soon I'll be sending out an email. We've identified government agencies that we think have an interest, and I've been meaning to get in touch with them. I'll do that very soon to let them know what we're proposing, and just to offer to have a chat about it, or give them an opportunity to give their thoughts.
Very good. I think that's everything from the chat. Does anyone else feel free to pop up a hand or put something else in the chat? Oh, here's something coming through. Is Kainga Ora on that list?
Yeah,
Andrew?
yeah, Kainga Ora, HUD, stats, and a few others, I think.
And I think Jared's just popped in another question, but I think he's chatting with Mike basically now. So I'll let Mike answer that. Is MPI on that list?
Not sure, but I don't think we did identify MPI, but I can add it. Yeah, if MPI has an interest, then definitely.
Are you happy?
Yeah, cool.
Are you happy for me to share that list, or with the presentation pack after, and any other ministries that aren't involved but are using it can put their hand up?
Yeah, sounds good. Yeah. So we're just trying to identify, who might have an interest. So to let them know what we're doing. Evaluation focus to the review, but definitely keen to talk to other agencies that use the data and have an interest. So
Yeah, terrific. Okay. Cool. I know we've got some people from valuation industry on the line and property industry. Any thoughts? Feel free to send them through to us or sing out. But yeah, we're more than happy to receive feedback on this and make sure we get this engagement right in the period before drafting any rules, and do that up front. Cheers, Miles. That's awesome. Sounds good. Yeah, so yeah, definitely taking a customer-led, engage upfront approach before we start actually drafting any new rules. So yeah, we'll be you'll be hearing more from us on this space. Is there an ETA on when local government consultation is likely to begin?
Yeah, I mean, planning for consultation on a draft set of rules early next year, but we'd likely be consulting with councils this year on the topic by topic stuff.
All right, and yeah, I'm sure, yeah, you'll be in touch shortly. You said you were going to message out some agencies and and start
That's
that
right.
consultation.
Yeah, so very shortly we'll be in touch. Yeah,
there'll be
because we're getting close to the
more
point
info.
of having our first engagement on the DVR proposal. So yeah, very shortly be in touch.
Cool. Well, if there's no more questions, we might just start to wrap things up. So yeah, thanks everyone. Thanks Andrew, and thanks everyone else who's presented today. Really appreciate your input and sharing your excellent case studies of what you're doing with property data or new things that are applicable to property. So I'll be sharing the slide pack and the recording in due course after the meeting, where they can be accessed. And we will a note on the base maps demo that we weren't able to do today. We will look to have a special session on that later in the month. So stay posted for that. And we'll send out another invite like we did for today once that date is confirmed. And then we have some updates on the network itself. We are working on a hub sort of landing page on the LINZ website where we can post up content and news about upcoming events and sort of links to register and links to other information. So we're in the process of making that, and that will come up in the next few weeks. We also looking at other new events that we can look at hosting. So things like sausage roll talks in person in the LINZ building, where people in Wellington to start with can get along and network and discuss property data and maybe hear a presentation, have a bite to eat, and looking at what we can do around the country when we are travelling to things like conferences, and can we do something on the sidelines of a conference, likes of Survey and Spatial coming up in August, the NZ Esri Users Conference in September, for examples. And I am also looking to form an organising committee to help organise these events. So if you are keen to be involved in that, do feel free to reach out. And yeah, we'll see what we can pull together. Yeah, we're very keen that this isn't just a LINZ event, that we are sort of hosting it and getting it up and running, but we're keen to really make this a shared network where we have joint ownership with others. So yeah, with that, I will just do the closing karakia and wish you good day. So, kua e te kaupapa, ka ria ngā hua, ka rere ngā arawai, kua mau te mātauranga, hei arahina ngā mahi o toitu te whenua, kia tau te rangi marie, ki runga i a tātou katoa, homie, huie, tai kie. Our work has come to a satisfactory conclusion. The fruit is growing. The waterways continue to flow. We now have the knowledge to lead and drive the work of Toitu Te Whenua. May peace settle upon us all. Gather and go forward together. Thanks everyone for your time and attention today. We really do appreciate it. Ka kite. Have a good one.
Thanks, Ben.
Thank you, Tim.
Thank you.